Doctor. My name is Dennis. Together with my group member Teng Wei Xiang, Lee Jun Yong, Ryan, and So Jin Wen, we're going to present about the case study of hazard identification, risk assessment, and the risk control at the Tibet Center. So let's move on to the introduction. What is Hirarc? Hirarc is developed by the DOS Malaysia. We introduced to the Hirarc guideline at 2008. It support the implementation of the occupational safety and health requirement. We should provide the system method to identify the hazard, assess risk, and implement the control measure. Hirarc is used by organizations to improve the workplace safety and compliance with the legal requirements. This study aims to identify the hazard at the Tibet Center of University Malaysia Police, which is the green building located at Unimap. And next, this study aims to assess the level of risk associated with the identified hazard based on their likelihood and severity. And lastly, is to propose the appropriate control measure according to the hierarchy of the control to reduce and minimize the workplace hazard.
The study area of the higher assignment is the TVEC Center Unimap, and we have chosen two workshops to proceed the hazard and risk assessment. The first one is IC Fabrication Teaching Center, managed by Dr. Saiful Rizam, and the main purpose of this workshop is for integrated circuit fabrication. The second workshop selected is Surface Grinding Workshop, managed by Puan Roslina. This workshop uses spinning abrasive wheels to shape the material surface to achieve a flat, mirror-like finish. The first hazard found in IC Fabrication Teaching Center is the inhalation hazard from uncovered soil. As you can see, the dry soil is leaving uncovered and it allows fine dust particles to disperse into the air, which may cause serious harm to the respiratory system. Furthermore, the bins are placed directly obstructed to the emergency stop button of the machine. The likelihood of this hazard is rated as 4 because regular student movement and ventilation airflow can easily cause the fine dust particles to disperse into the breathing zone. The severity is rated as 2 as inhaling these particles may cause coughing or temporary breathing discomfort. So the overall risk level is 8, which is a medium rating. To handle the risk, all plastic bins must be closed with tight-fitting lids immediately after use, and all operations related to soil should be conducted under a ventilation system. The lab management must also strictly enforce housekeeping in IC fabrication area. The lab's SOP must incorporate a mandatory pre-operation checklist to verify the surrounding of workstation is clear. Finally, the instructor and student participating in activity related to soil must be required to wear appropriate respiratory protection such as an N95 respirator or a high-efficient particle mask.
Next, this is the hazard tool found in the IC Fabrication Teaching Center at the green building. As you can see in the picture, there is the improperly parked pallet lifter. It may cause the obstructing workplace walkway and the movement. People may trip over or collide with the equipment, causing the injuries such as bruises, sprain, or fall. It also will block the access to the workstation and also the emergency room. Next, this is a risk assessment for the hazard tool. For likelihood, I'll put it 3. Severity, I'll put it 2. And lastly, we'll get the 6, which means the medium risk level for this hazard. For hazard 2, I propose 2 control measures. The first one is the engineering control, which provide a designated parking area for the pallet lifter, clearly demarcate and separate the parking area from pedestrian walkway. It will reduce the risk of tree collision and obstruction in the workplace. The second control is the administrative control. We can provide the safety awareness training for the operator and the staff on the proper handling and storage procedure. And also install the safety signal indicating the desired parking zone.
I'm Lee Jun-yong, and now I will present hazard 3, which is the cutting and crushing hazard associated with the shearing machine located in the surface grinding workshop at the Tibet Center. This machine is used to cut metal sheets using a high-force moving blade. During operation, the operator's hands may be positioned close to the cutting area while feeding or aligning materials. As a result, there is a risk of accidental contact with the blade, which may lead to severe cuts, crushing injuries, finger amputation, or permanent disability. In addition, sharp metal of cuts may also cause secondary injuries such as cuts and lacerations. To assess the level of risk, a risk assessment was conducted. The likelihood is rated as level 3, which is conceivable because the machine is frequently used and operators work close to the blade during normal operation. The severity is rated as level 4, which represents fatal or major injury, due to the possibility of serious injuries such as crushing, amputation, or permanent disability. Therefore, the total risk score is 12 based on the risk matrix. This hazard is classified as high risk and requires immediate control measures to reduce the risk to an acceptable level. Several control measures are recommended to handle this hazard. First, engineering control should be implemented by installing interlock guards around the blade area to prevent accidental contact. The emergency stop button should also remain easily accessible, and regular inspection and maintenance should be carried out to ensure the machine operates safely. Second, administrative control should be introduced through the implemented of standard operating procedure, operator training, competency assessment, and warning signs. These measures help ensure that users understand the hazards and follow safe operating practices. Finally, personal protective equipment, which is PPE, must be worn at all times. This includes safety gloves to protect hands from sharp edges, safety goggles to protect the eyes from flying metal fragments, and safety shoes to protect the feet from falling materials and metal of cuts.
Moving on to hazard 4. It is located in the surface grinding workshop. As shown on the slide, the plastic protective casing of the electrical control switch is heavily damaged and is held together with electrical tape. This leaves the internal high voltage part fully exposed to anyone using the equipment. Because operators frequently handle this switch, the likelihood is rated as a 4. Direct contact with this switch carries a fatal severity due to the risk of electrocution. This results in a critical risk score of 16, requiring an immediate operational halt under the DOSH guideline. To address this risk, we propose 3 controls. The first is to eliminate the hazard by completely disconnecting the machine from the power supply. Second is to use engineering controls to install a new industrial casing with IP65 protection. The third is to apply administrative control by enforcing strict lockout-tagout rules and carrying out daily checks before the work begins.
Hi, my name is Oh Jing-wen. Today, I want to highlight the hazard 5, which is a fragile grass ship was found less unsecure and without any warning sign on top of an elevator grinding machine. This type of hazard is categorized as physical hazards and caused by improper storage of fragile material. How does the hazards occur? Normal grinding operation cause the grass right off the edge. Combined with high student and staff foot traffic, a simple accidental knock with a tool could send it running down, shattering it into hazardous and sharp fragments. Our risk assessment rates this as a medium risk with a level of 9, with likelihood rate as 3 because of accidental contact during normal workshop section, severity rate as 3 because some potential injured that are require medical treatment, for example, cut and laceration, punctured wounds, ice injured. To mitigate this, we are informing the hierarchy of control outline. The first is elimination. We must completely remove grass sheep from elevator position after use and place them in designated storage area. Next is engineering control. We need to install dedicated rack and secure any use with GFM. Next is administrative control. We will conduct tri-weekly 5S housekeeping, mandatory briefing for all workshop users. The last is personal protective equipment, PPE. We must wear the lab jacket and shoes before entering the slab to protect the body and protect and falling glass fragments, and wear the goggles to protect eye injury.
Now, I want to discuss regarding the safety and health of this project. For the society, ignoring these risks result in accidents that could cause emotional hardship and heavy financial loss for the families. It also weakens the public confidence in TVET institutions. Managing this hazard properly creates a safe and dependable place for learning. It also lowers the healthcare and support costs linked to injuries, which reduce the pressure on Malaysia's social systems. For the environment, our focus is to maintain good indoor air quality and proper workspace hygiene. For example, hazard 1, which is uncovered dry soil. It could harm the respiratory health by spreading dust through the air. Through this project, we successfully contain these airborne particles, protect the health of everyone in the area, and keep the work safe, clean, and safe.
In conclusion, this evaluation successfully assessed the safety condition at the Tibet Central University Malaysia Police. Beyond this medium risk and secure glass panel, we also identify other hazards including uncovered salt bin, incorrectly parked pallet lifter, and high-risk issues like a damaged electrical casing and shuttering machine hazard. Implementing this corrective control and committing to regular inspection will ensure we keep our workshop safe, accident-free, and fully compliant with OXA 1994. That's all from us. Thank you.